Remember, the difference was if we are talking about the distribution of the sample means. The sample means, that's talking about that X bar. And so then if we knew the data was normal, then we had to get our z-score and then use our normal table, like we had been doing in Chapter 7. The mean for the sample means is the same as the regular mean, but how did we find the standard deviation in this scenario?
Standard deviation divided by and square root of n.
Yep. The sample, or the standard deviation for the sample means is the population standard deviation divided by the square root of n. And then we finished up, we had said, okay, but if our data isn't really normal, we can't do all of this. But then we had that result that said, as long as your sample is big enough, it will start to look normal. And how big did it have to be before we can assume it's normal? 30. So from now on, if we know our sample is 30 or more, we can automatically say it will be normal. If it is less than 30, I have to tell you that the data is normal for us to be able to do all of this. So let's look at example 6. Suppose that the mean time for an oil change at a 10-minute oil change joint is 11.4 minutes, and the standard deviation is 3.2 minutes. So my mean is 11.4, standard deviation 3.2. And that is for the population, because this doesn't say the sample means or anything. This is just for the regular population. So part A, if a random sample of n equals 35 oil changes is selected, describe the sampling distribution of the sample mean. So several of your homework questions will say describe the sampling distribution. When I ask that, there's really 3 things you need to do. Did I say anywhere that this data was normal? No. Can I assume it's normal? Why? Okay. So you need to, you don't have to give me a lot of justification for that, but I need to know you thought about it. So I am going to say it is approximately normal. And the reason there is, again, just because my n is bigger than 30. I know that. So when I say on your homework questions, describe the sampling distribution, you better state that it's normal. If it's not given in the problem, we have to make sure our n is big enough to count it as normal.
If it's less than 30 and it doesn't say it's normal, is that unusual?
Then we won't be able to do it. So I would have to tell you either one or the other for us to be able to do it with what we've learned so far. Then the other things I want with describing the sampling distribution of the sample mean, I want the mean and the standard deviation for the sample means. So that's what I want, those 3 components, stating that it's normal, the mean, and the standard deviation. The mean of the sample means, we said yesterday, is the same as the regular mean, so that would be 11.4. Yesterday, standard deviation of the sample means we had on our formula sheet. That's your regular standard deviation divided by the square root of n. And I told you keep several decimal places here. The more you round, it can throw off some answers later on. So we get 0.540,899. So several of those homework questions are going to say describe the sampling distribution. Those are the components that I want. Part B, if a random sample of n equals 35 oil changes is selected, what is the probability that the mean oil change time is less than 11 minutes? I want the probability that the mean, so x bar, is less than 11. All right, we know if we want to use our normal table, we have to convert this into a z. So you're looking here. If this were just in regular x, then you would be using the regular mean and standard deviation. Oh, sorry, since this is x bar, I need to use the mean and standard deviation for x bar. So your mean and standard deviation have to match the variable that we have. So to get my z, you do your x, so your value, minus the mean for x bar, divided by the standard deviation of x bar. And that gives me a negative 0.7. We have to round to 2 decimal places for the table, so negative 0.74. So what we're finding is the probability that z is less than negative 0.74. The table gives us the less than. So we just look up, go down to negative 0.7 over to 4, and we get 0.2296. So there is only about a 23% chance that our mean will be less than 11 minutes. Okay, if I had asked you, let's ask this question. What's the probability that a randomly selected oil change is less than 11 minutes? How is that different than the question I just asked? Right. The other one was, okay, we've got a group of 35 of you. If I find the average time, what's the probability that that average time of the entire group is less than 11? This one is saying, okay, I'm going to go get my oil change. What's the probability that my time is less than 11 minutes? If I were going to do this one, what variable would I put here? X. So then when you find this z, what mean and standard deviation are you using? The original. Do you guys see the difference between when we do which type? This is like what we were doing last week. We weren't just talking about one particular instance. So you're going back to your original mean and standard deviation. What was it, 3.2?
Yeah.
So I get a negative 0.125, so negative 0.13. So this time I'm finding the probability that z is less than negative 0.13. So if I look that up, we get a 0.4483. So there's almost a 45% chance that my oil change will take me less than 11 minutes. But if all of us went and we found our average, there's only about a 23% chance that our average would be less than 11 minutes. Okay, I just want to make sure you understand when we do the sample mean versus when we do the regular. Do you guys see the difference here? Let's look at one last example. So the mean weight gain during pregnancy is 30 pounds with a standard deviation of 12.9 pounds. An obstetrician obtains a random sample of 35 low-income patients and determines their mean weight gain during pregnancy was 36.2 pounds. Does this result suggest anything unusual? So what would unusual be?
Less than 5%.
Less than 5%. So what we have to do is find this probability and then see, is that less than 5%? So I want to find the probability. Okay, is my variable x or x bar here? Right, I'm looking at the mean of this group. So that's x bar. And we want to find, we're trying to decide if this is unusual. We know that normally it's about 30 pounds, so to decide if it's unusual, we're going to find the probability that it's more than this. Okay.
Is there a difference when it's like greater than and equal to this?
No.
Okay.
So the equal to doesn't change anything. Good question. All right. Did I say that this was normal? No. Can we assume this? Yes. My n is greater than 30, so that tells me it is normal. All right. What does my sample mean? 30 pounds, same as the mean of the whole population. The standard deviation for my sample means. So normal standard deviation is 12.9 divided by the square root of 35, because that was my n. And we get 2.18049. So now let's change this to a z. So z is your value minus the mean divided by the standard deviation. So get a z of 2.84. So I'm trying to find the probability that z is greater than that. For greater than, what do we do? Okay. So 2.84 gives me 0.9977, and that is 0.0023. So is this unusual?
Yes.
Yes. What that means is one of two things. Either we had a poor sample, so we just picked a bad group, or maybe we picked a group that had a lot of underlying health problems that contributed to this. So either the sample we had didn't really represent true population, or since this is so unusual, it could mean the sample had a different mean. In other words, maybe that low-income group does have a higher average weight gain in comparison to the whole population. So when you find these unusual results, you have to ask yourself why. And it's because something about my sample is different. Either they don't really represent the full population, or that particular group does have a different mean for some reason. All right, any questions for me? So I just wanted to give you guys time to work on this assignment. It's on your notes handout there, and you've got quite a bit of time. Depending on how it goes, I may or may not introduce the next section at the end of